Hey guys, welcome back. My name is Amia. In this episode, we're gonna look at elastic load balancing in EC2 Auto Scaling. ELB stands for Elastic Load Balancing. Elastic load balancing automatically distributes incoming application traffic to multiple EC2 instances to prevent traffic overload on a single instance. ELB can send traffic either in a single availability zone or across multiple availability zones for high availability. In case an instance fails or even an availability zone fails, ELB will automatically stop sending traffic to that instance or the entire availability zone. There are three types of elastic load balancing. Application Load Balancer, or ELB, operates at level 7 of the OSI model, which is the application layer. Network Load Balancer, or NLB, operates at layer 4 of the OSI model, which is the transport layer. Classic Load Balancer is the previous generation load balancer which operates at both layer 4 and layer 7. AWS encourages you to use either Application Load Balancer or Network Load Balancer. With ELB, you only pay for what you consume. You are charged for the running hours and load balancer capacity units, LCU hours. Amazon EBS offers free tier for the first 12 months. You get 750 hours running time per month for application load balancers or classic load balancers, and 15 LCUs for application load balancers, 15 GB data processing of classic load balancer. OSI stands for Open Systems Interconnection. OSI Model is a conceptual model to guide vendors and developers and facilitate clear functions of networking and digital communication products. There are 7 layers in OSI Model. Layer 7, the application layer, enables end-user communication, such as web apps, mobile apps. It supports HTTP and many other protocols. Layer 6, the presentation layer, translates data for the application layer based on the syntax of application, handles encryption and decryption for the application layer. Layer 5, the session layer, coordinates conversations between applications, handles authentication and reconnection after interruption. Layer 4, the transport layer, transfers data across a network and controls the data flow. It supports TCP, UDP, TLS traffic. Layer 3, the network layer, moves data through other networks. Layer 2, the data link layer, moves data into and out of a physical link in a network. Layer 1, the physical layer, transports data using electrical signals. Each ELB operates at different layer. ELB, Application Load Balancer, operates at layer 7. It's best suited for the load balancing of HTTP and HTTPS traffic. ELB provides advanced request routing targeted at the delivery of modern application architectures, including microservices and containers. NLB, Network Load Balancer, operates at layer 4. It is best suited for load balancing of TCP, UDP, and TLS traffic where extreme performance is required. It's capable of handling millions of requests per second with ultra-low latencies. Classic Load Balancer operates at both layer 4 and layer 7. It provides basic load balancing for EC2 instances. Classic Load Balancer is a previous generation load balancer. It is intended for applications that were built within the EC2 Classic network. EC2 Classic is replaced by Amazon VPC now. This diagram shows why we need elastic load balancing. Initially, we have created an application and launched a single EC2 instance to serve a few users. This architecture might work in the beginning. Later on, when our application gets popular, the EC2 instance begins to serve more traffic from more users. With a single instance, we are not able to quickly respond to the traffic increase. Our instance may begin to experience traffic overload. If the instance fails or the entire availability zone fails, our application will lose availability. We have to launch another instance and redirect the traffic. It might take a very long time to recover. Our users will experience significant downtime. So how do we avoid the single point of failure? We can avoid a single point of failure by using elastic load balancing. Here is how it works. There are a few EC2 instances behind an elastic load balancer ready to serve the traffic. When the demand increases, ELB automatically distributes traffic across all EC2 instances. It sends an equal amount of traffic to avoid a single instance being overwhelmed. ELB can send traffic to instances across multiple instances to provide high availability. In case an instance fails or even the entire availability zone fails, ELB immediately detects the failure and stops sending traffic to failed instances, and redirects traffic to healthy instances. You might ask, what if an ELB fails? What if ELB is the single point of failure? ELB has the built-in high availability feature. Amazon Elastic Load Balancing guarantees at least 99.99% monthly availability. Under the ELB, there are many load balancing servers. AWS manages these servers to provide high availability. EC2 Auto Scaling helps you maintain application availability and allows you to automatically add or remove EC2 instances based on the scaling policy you define. For example, it can automatically add or remove EC2 instances based on CPU usage, network, and requests. To use EC2 Auto Scaling, we need the following components. A launch configuration or launch template is needed as a configuration template of EC2 instances. You need to specify AMI ID, instance type, size, security group, key pair, and EBS volumes. EC2 instances are organized into an auto-scaling group, so that they can be treated as a logical unit for scaling and management. When you create an auto-scaling group, you can specify the minimum, maximum, and desired number of EC2 instances. Auto-scaling group uses a launch configuration to launch EC2 instances. You need to define the scaling options. You can scale instances manually, or set a fixed schedule based on time, or set dynamic scaling with a scaling policy based on CPU usage, network, or requests. You can put an auto-scaling group behind an elastic load balancer. ELB will automatically send traffic to the newly added instances. It's very common to use auto-scaling and ELB together. There is no additional charge for AWS auto-scaling. You pay only for the AWS resources needed to run your applications and Amazon CloudWatch monitoring fees. For example, you'll pay for additional EC2 instances added by auto-scaling. Here is how it looks like when you use auto-scaling with ELB. We have an auto-scaling group using dynamic scaling with a minimum of 1 instance and maximum of 3 instances. The auto-scaling group is behind an ELB. Currently, there is 1 instance running to serve the traffic. When we have more users sending requests, auto-scaling detects the increasing traffic and launches a new instance. Once a new instance is up and running, ELB sends traffic to the new instance. Auto-scaling launches additional instances, based on the incoming traffic, until reaching the maximum number of instances defined in the auto-scaling group. Once auto-scaling has reached the maximum number of instances, it won't add any new instances, even there are more incoming traffic. If an instance fails, auto-scaling will remove the instance from the group. ELB will stop sending traffic to the removed instance. A new instance will be added to the auto-scaling group. Once it's ready, ELB will send traffic to this instance. When we have fewer requests during after business hours, auto-scaling will remove underutilized instances until there is only 1 instance left. It's the minimum number of instances we have specified. Auto-scaling and ELB work together to provide highly available, highly responsive traffic handling for your applications, and make sure you have the right amount of resources up and running. So you only pay for what you consume. In this episode, we've learned elastic load balancing and EC2 auto scaling. ELB can automatically distribute traffic to EC2 instances across multiple availability zones. There are 3 types of ELBs: Application Load Balancer, ALB, Network Load Balancer, NLB, and Classic Load Balancer, which is the previous generation. ELB has built-in high availability features and can help avoid a single point of failure. EC2 Auto Scaling automatically adds or removes instances based on conditions you define. To use auto scaling, you need to create a launch configuration or template, auto scaling group, and specify scaling options. We have manual scaling, scheduled scaling, and dynamic scaling options. You can use EC2 auto scaling with ELB. Conceptually, you need to know how they work together. Okay, that's all for elastic load balancing and EC2 auto scaling. Thanks for watching and see you in the next episode. Hope you've enjoyed watching this episode. If you liked the video, please help us and hit the like button. If you want to watch more tutorials, please subscribe to the Cloudemy TV channel. Make sure to turn on the notification and stay tuned. At Cloudemy, we're passionate about cloud and AI technology. Please share your feedback and thoughts in the comments below. Feel free to let us know what topics you'd like to watch. Happy watching and happy learning.